Today we are going to create a very useful tool in our study of trigonometry called a unit circle. So you need to get yourself a blank piece of paper, make a big circle, not so much that it fills the whole paper, but not so small that you can't add to it. Now, my screen has a bunch of concentric circles. I'm just talking about the big circle on the outside. So we need a big circle, and you can draw these lines that cut it in half. Something to note about this, it's called a unit circle not because it has a bunch of units on it. We're going to add a bunch of things to this, but it's called a unit circle because the radius, the measure from the center to the outside, is 1 unit long. And that's what gives us all of our values that we're going to talk about. So the first thing you need to do with your unit circle is you need to mark 0 degrees, which is over here on the right, 90 degrees, 180 degrees, and 270 degrees. Now, something to note over here at 0 degrees is also 360 degrees. So it's kind of a double use there, and you're going to find more and more of these actually have double values. But for our purposes today, these are the first 4 we want you to mark. Now, because this is a unit circle, these points actually have coordinates. This would be at 1, 0. So we're going to go ahead and mark that. Up here at 90 degrees, this would be at 0, 1. So we're going to mark those coordinates. Over here at 180, we're going to go -1, 0. And down here at 270, we're going to go 0, -1. So now you can see this is why we call this a unit circle. As I said, that radius is 1 unit long. The next thing we're going to do is we're going to cut each section in half. And we're going to remark these 45, 135, 225, and 315. Our angles are all going to measure from this 0, and they're going to measure counterclockwise. So up here in the first quadrant, we're going to have 45 degrees. Second quadrant, we're going to have 135 degrees. Third quadrant, we're going to have 225. And the fourth quadrant, 315. Now, we also need to put values with these, okay? And I'm going to explain this a little bit. But at 45 degrees, the two values that are here are actually the same number. We have square root of 2 over 2. That's the x, that's the y, they're the same number. I go the same distance in the x as I go in the y. If I go to this next slide, you can kind of see how I did this. I go x, I go y. Notice that the x and y are the same value. If you think back to our study of triangles and right triangles, this would be a 45, 45, 90 if I would mark my angles. So that means these two sides are the same because these two angles are the same. And here's our hypotenuse of 1. So that's why 45 degrees has the same values. And you'll notice when that gets repeated over here, when I talk about making that angle, I'd have a 45, 45, 90. Those two sides are going to be the same. So if we go back here and we fill this in, we're going to have the same values, but now the x is going to be negative. So we're going to have negative square root of 2 over 2. Positive square root of 2 over 2. So we're going to go ahead and write that in. If we move down to the third quadrant, both the x and the y are negative, but the numbers still don't change. Negative square root of 2 over 2, negative square root of 2 over 2, just that they're both negative. And down here, we've got the x is positive, so we got square root of 2 over 2. But the y is negative, square root of 2 over 2. So now I should have the 4 coordinate marked, and they should have their values. We did that on the previous one. And I should have the in-between ones marked with their x and y value. The last things we're going to mark is we're going to go in between again. So now we're going to talk about a 30 degree and a 60 degree. So I'll change colors here. So if I wanted to put the 30 degree angle down here in the second quadrant, we'd actually be sitting at 150 degrees. If I add one down here in the third quadrant, we're sitting at 210 degrees. And if I put one over here in the fourth quadrant, we're sitting at 330 degrees. So we're going to go ahead and add those to our unit circle as well. Now I'm going to change colors here to kind of match the 60. If I wanted a 60-degree angle in the second quadrant, we're sitting at 120 degrees. We're going to put one down here in the third quadrant at 240 degrees. And we're going to put one in the fourth quadrant here at 300 degrees. So now we have all of our angles marked in degrees for our unit circle. So that concludes all of the angles that we want on our unit circle, but now we need to add those x and y values. Now I showed this slide about how x and y are the same, but let's look at a 30-degree angle. Now obviously the x is a little bigger, so we need to find out what that value is. And remember, our radius is still 1, that's why we call it a unit circle. So if I go back here to 30 degrees, the x value is actually square root of 3 over 2. The y value is 1/2. And we leave them as fractions. We don't turn them into decimals, but square root of 3 over 2 is still bigger than 1/2. If I move over here to the 150, I'm going to have the exact same values of square root of 3 over 2 and 1/2. I just need to know which one is going to be negative or positive. In this case, the x is negative. Now, if I go down here to the 30 degrees, same values again, but this time, both of them are going to be negative for my x and my y. And over here at 330, the x is going to be positive this time, and the y is going to be negative. So there I have my 30-degree angles. Now, the interesting part, if you can remember 30-degree angles and which one comes first, when we move up here to the 60-degree angle, the x and the y actually switch places. So now, the x is 1/2, the y is square root of 3 over 2. And at 120, the x is still 1/2, the y is negative square root of 3 over 20, or over 2, excuse me. Down here at 240, both of them are negative. And over here at the 300, the x is positive, and just the y is negative. And let me fix my mistake up here in the second quadrant. My mistake. This should be positive, the x should be negative. I marked the wrong one there. So now I have all of my unit circle angles marked, and I have all of my x and my y values marked. So I'm going to go back to this slide, and I want you to think about your trig functions, and I want you to think about cosine. So if I'm sitting at this angle right here and I think of cosine, cosine is adjacent over hypotenuse. Sine would be opposite over hypotenuse. Well, if the hypotenuse is 1, then the cosine value is whatever x is. And the y value is whatever, or the sine value is whatever y is. So if I go back to my picture here, I have all these x and y values. Those x and y values also happen to be cosine and sine values for all of the angles. So for instance, here at 30 degrees, the cosine of 30 degrees is square root of 3 over 2. The sine is 1/2. If you look at 0 degrees, the cosine would be 1. The sine of 0 degrees would be 0. If I go over here to 135 degrees, the cosine is negative square root of 2 over 2. The sine is positive square root of 2 over 2. So I have all the common values that I would normally use with some of my triangles, some of my trig, and I have their cosine values and their sine values. Now I'm going to take it one step further, because think about what tangent would be. Tangent is opposite over adjacent, in this case, y over x, which happens to be sine over cosine. So even though I haven't specifically written down the tangent values, the fact that I have both sine and cosine tells me that the tangent values are also on my unit circle. So this is going to become a very useful resource for us as we move forward and start learning about different angles, their sine values, their tangent values, their cosine values, things like that. You should have all these marked in. Now I put this last slide up here just to kind of show you how these angles lay out, because obviously 30 degrees from 0 to 30 goes up by 30, but from 30 to 45 is 15, 45 to 60 is 15, but then we make another jump. There are some other ones in between, but they're not as common, not as used by us. There's a 15 degree here, there's a 75 here. And I only point that out because it makes it easier to count them. If I count by 15s, I go 15, 30, 45, 60, 75, 90. The ones that we're worried about are the ones we put on there. We're not going to add the 15s and the 75s and the 105s. We're not going to add all those. What we have is what we're going to use, but you should now have all of the angles marked, 30, 45, and 60 in each quadrant. You should have a cosine and sine value for each of them. Some little things that a few people like to add. They may want to number these so they know which quadrant is 1, which quadrant is 2, and so on and so forth. Some people like to mark which one's cosine and which one's sine. So you will see a few people add the fact that it's cosine first, then it's sine. And they'll put that somewhere on their unit circles so they know which value is which. I will have a few people that will add the tangent is sine over cosine. You can certainly add that as well. Some people like to do this. So they know in the first quadrant, both the sine and the cosine are positive. Over here, they know the cosine is negative, the sine is positive. Down in this quadrant, they're both negative. And in the last fourth quadrant, the cosine is positive and the sine is negative. Now you can find unit circles all over the internet, in textbooks, things like that. So if you want to go find one, you certainly can. There's going to be a few more things we add to this, but for the most part, this is the resource we wanted to create so that we can use it to answer some questions and do some things with angles.